going to do 10 chapter 10, section 6, trigonometric ratios. Trigonometric is often abbreviated as trig. So you know you're in the big boy club when we are talking about trigonometry. Good job, guys, you made it. Celebration. Our learning objective is to find and use trigonometric ratios, which are ratios of the side lengths of a right triangle. So firstly, we can only apply these to right triangles. So double highlight right triangles. If it's not a right triangle, we are not using trigonometric ratios. And the second thing that I want you to look at is the word ratio, which is not one. Because ratio means fractions. So we're going to be taking a look at fractions of right triangles. Not too hard. Okay. So when we see sine A, what it means is that my angle A, the sine of A is the leg opposite, so whatever this length is, divided by or over the hypotenuse. You can identify the hypotenuse because it's the longest side. We did that in the Pythagorean theorem section. So the sine of A is a ratio between the opposite side and the hypotenuse. To identify opposite, you just go to the one across from that angle. If we look at cosine of A, here's the long way to write it. Here's the shorthand. This is not cos A, it's cosine of A. It's the length of the adjacent side. So the adjacent side is the one right next to the angle, divided by the hypotenuse. So it's just a ratio. All it is a nice little fraction. And then the tangent of angle A, abbreviated as tan A, is the length of the opposite side divided, the length of the opposite side divided by the length of the adjacent side. So all we're doing is we're taking, it's just a way to name different little fraction combinations. All right, so let's use this sample triangle and find the sine, cosine, and tangent. Now, I will pass along the wisdom that I was given 25 years ago about sine, cosine, and tangent. In the ancient islands of Fiji, there is the trigonometry god, and when we want good crops or productive rain or rain to stop, when we want to do our appease the gods, we do the Soka-toa chant. Soka-toa, Soka-toa, Soka-toa. And the Soka-toa chant is actually to help us remember that sine is equal to opposite over hypotenuse. There's your so. Ka is adjacent over hypotenuse. There's your ka. And then toa is for you to remember tan is opposite over adjacent. And I should use, I'm actually going to use different letters. So anyway, that's wisdom I'm imparting upon you so that you can remember the trigonometry ratios and appease the gods and ask them, please, might I have a good grade on my trigonometry test? So we do the chant, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Okay, so let's find our ratios. And if you look, we are concerned with E, so the first thing I do is circle the angle that we're concerned with, because my opposite and my adjacent are going to be determined by which angle I'm looking from. So my sine of E is my opposite side over my hypotenuse, and my opposite side has a length of 9, and my hypotenuse has a length of 15. And let's reduce this down because I know 3 goes into both of those. So 3 goes into 9 3 times, and 3 goes into 15 5 times. So the sine of E is 3/5. And that's it. That's the answer. 3/5 is the answer. Nothing else. Nothing more. Nothing crazy. Cosine E is the adjacent over the hypotenuse. And the adjacent side is 12, so one right next to the E. And we determined the hypotenuse was 15. So we're going to reduce that down, and 3 goes into both of those. So the cosine of E is 4/5. And lastly, but not leastly, we have tan of E, and that is the opposite side over the adjacent side. And the opposite side is 9, adjacent side is 12. That reduces down to 3/4. All right, now I'm going to show you guys how to use your calculator to do the trigonometric ratios. Your calculator is not going to make it a nice fraction like 3/5. It's going to give you a decimal. So just be ready for that. But it's terribly easy. The worst part is making sure, you guys see that this is sine of 80 degrees, making sure that your calculator is in degrees mode. If it's in the wrong mode, you're going to get the wrong answers. So now is a good time to check your calculator. This calculator likes the 80 first, and we are just going to apply the sine. Boop. So it's 0.9848. And that's as hard as that gets. Tangent of 45, my calculator likes 45 to go in first, and then I apply the tangent operation, and it is equal to 1. No. It's doing something crazy. Tangent of 45 is 1. Thank you. And then we do the same thing with cosine. 0.9659. So these are just ratios. And then the sine of 9. 0.1564. Alright, so I want to talk to you guys about angle of elevation or angle of depression. And I definitely want you to make note of this. The angle of depression is if your line of sight is parallel to the horizon and the angle you're looking for goes down. And then angle of elevation is if you're on the ground and you're looking up. So depression is where your line of sight is lower than your eyesight. Angle of elevation is where your line of sight is above your eyesight, your eyeball level. Okay, so let's look at this problem together and then we'll answer this sample question. We're going to use trigonometry to roll this up. Okay, suppose you're waiting in line for a ride and you're here with all these other people in the bottom and you see your friend at the top of a ride. How far, boop, boop, from the base, how far are you from the base of the ride? And because you have nothing to do but watch the informational flyers on your way in the line, you know that it's 150 feet tall, and I think you've gotten your protractor out and calculated that it's 20 degrees angle of elevation. So when you get a word problem, always draw the picture. Circle the angle that you care about. Right now I care about this 20 degrees. And circle the sides you care about. I care about the length to the ride, and I care about the height. And then determine how these guys are related to your angle. So this x, this length here on the bottom, is adjacent to my 20 degrees. And this length right here, this height, is opposite. And when we consult our tangent, our trigonometry gods, we know that SOHCAHTOA which one uses only the opposite and the adjacent? Taham. So when we consult our ancient oracles, we know that we're going to be using the tangent. So we go, okay, tangent of 20 degrees, it's the opposite side over the adjacent side. We know that the opposite side is 150 degrees. We know that the adjacent is x. And we can actually, all this is a chug in our calculator, tangent of 20. So what they did was, to solve for x, all you have to do is cross multiply. So you go tangent of 20 degrees times x and 150 times 1. So I just put tan of 20 over 1 and I cross multiply. So now I don't have a fraction, but I have a statement here. The next thing we're going to do, so we can solve for x, is divide by tan of 20 degrees. And 150 divided by the tan of 20 degrees is a simple calculator check. So you got 150 divided by tan of 20 equals 412.12. We want to round to the nearest 10 feet. We get 410. All right, so let's take a look at what our practice question is asking. After you move forward in line, the angle of elevation to the top of the ride becomes 50 degrees. So let's put that in, draw a nice little picture. So we're here. That did not work out the way I wanted to. Try that one more time. So we're here. Our angle of elevation is now 50. We're going to have a new x value. So we're just going to rewrite Our tan equation, instead of 20 degrees, we're going to have 50 degrees. 150 is going to be the same. X is going to be the same. So I'm going to put this over 1, and I'm going to cross multiply because I love cross multiplying. When I do that, I get x times the tangent of 50 degrees is equal to 150. We've already solved this once, but it's good practice to solve it again. I'm going to divide by tan of 50 degrees so that I can solve for x. And x equals a simple calculator chug. 150 divided by tan of 50. 125.86. And I believe we're going to round to the nearest tenth, so that's 130. Oh, that's huge, man. And that's feet. Because I rounded to the nearest 10 feet.